Here consider an LTI system with the input x of t and output y of t. The input Fourier spectrum, that is our x of f, is given here. We have to find out the energy of the input x of t. Okay, so x of f is given here, which is equal to sinc f minus 10 raised to 6 plus sinc f plus 10 raised to 6 into e raised to minus j pi f. Okay, now we have to find out our x of t. To find out our x of t, I am just going to take each of this individually. Okay, first of all, I am going to take our sinc f. What is the inverse Fourier transform? That is the time domain. We are going to find out x of t, right? So we have to convert this Fourier transform into its corresponding time domain signal, that is our x of t. So to find out x of t, what contributes, what signal in the time domain gives a signal that is sinc f in the frequency domain? We know that a rectangular signal with time period tau will yield us a sinc function, right? This is the Fourier transform pair. So from here we know that we understood that this sinc function came into being because of a rectangular function in the time domain. Okay, so we will see what is a, t and everything. First of all, this is a sinc f. I am just going to take sinc f only, then we will shift take the shifting into consideration. Okay, so sinc f, our a is 1 here and our t is also 1. So from here we know that our amplitude is 1 as well as our time period is also 1. So this will be rectangle t divided by 1. Okay, that's all. So sinc f is minus 1 by 2 to minus 1 by 2. I'm just calling it, okay, it's okay. Okay, minus 1 by 2 to 1 by 2. This is our rectangle t. Okay, and now we will see sinc f minus 10 raised to 6. That means there is a shift in the frequency domain. So how does a shift in the frequency domain come into being? We will have to look at the properties of Fourier transform. Here, if x of t is having a Fourier transform x of f, and if x of t is multiplied by e raised to j 2 pi f c t into x of t, and then the Fourier transform, if it is taken, we will get a Fourier transform f minus fc. Okay. Okay, if here it is plus, here it will be minus, and similarly e raised to minus j into 2 pi f c t, x of t will give us x of f plus sc. Okay, that is how it is. And now here we have sinc f minus 10 raised to 6. Actually sinc f have a Fourier transform, inverse Fourier transform rectangle t. So to get a sinc f minus 10 raised to 6, then this rectangle should have been multiplied by e raised to j 2 pi, instead of fc should have been 10 raised to 6 t into rectangle t. Okay, got it? So sinc f minus 10 raised to 6 was because of e raised to j into 2 pi 10 raised to 6 t into rectangle t. And now sinc f plus 10 raised to 6 will be e raised to minus j 2 pi into 10 raised to 6 t rectangle t. So we'll keep that aside, and now we can see we are taking it step by step. Okay, actually our x of f equal to e raised to minus j pi f sinc f minus 10 raised to 6 plus e raised to minus j pi f sinc f plus 10 raised to 6. We have done until sinc f minus 10 raised to 6 and f plus 10 raised to 6, but actually the Fourier transform is e raised to minus j pi f into sinc f minus 10 raised to 6. We will use the property once more here. Another property, that is time shifting property, that is x of t having a Fourier transform x of f, and if x of t is shifted by say t0, then we will have a Fourier transform which is equal to e raised to minus j into 2 pi f into t0. If it is negative here, here it will be negative also. Okay. In the frequency shifting case, it is the opposite. If it is negative in the time domain, it will be positive in the frequency domain. Here it will be the same. Okay, please keep that in mind. Minus e raised to minus j 2 pi f t0 into x of f. Okay, and now we can find that here it is multiplied by e raised to minus j pi f. Okay, that means our x of t is rectangle of t, right? So if there was a shift sinc f and e raised to minus j into 2 pi 10 raised to 6 t into rectangle of t was sinc f plus 10 raised to 6, right? And now what happens? E raised to minus j into 10 raised to 6 t, j 2 pi, right? 2 pi into 10 raised to 6 t rectangle t minus t0 give us e raised to minus j into 2 pi f into t0 sinc f plus 10 raised to 6. Okay, so we have to find out this t0. So actually we have e raised to minus j into 2 pi f into t0. Instead of this, actually we have e raised to minus j pi f, right? So that is it, e raised to minus j pi f. That means our t0 should have been 1 by 2, right? That means if it is 1 by 2 only, we will get this answer, right? E raised to minus j pi f. So our x of t is actually equal to, instead of t0, it is minus 1 by 2. Okay, so instead of x of t, I can write instead of x of t, what is it first? E raised to j into 2 pi 10 raised to 6 t into rectangle t minus 1 by 2 plus e raised to minus j into 2 pi 10 raised to 6 t into rectangle t minus 1 by 2. And now we will simplify it. We will take rectangle t minus 1 by 2 outside, e raised to j into 2 pi 10 raised to 6 t plus e raised to minus j into 2 pi 10 raised to 6 t. Okay, this is cos theta equal to e raised to j theta plus e raised to minus j theta divided by 2. This is similar to that, so we will convert it into the cos theta terms. So it will be rectangle t minus 1 by 2 into 2 cos 2 pi 10 raised to 6 t. Okay, so we got until there. And now we will see our energy, right? Actually our rectangle which is shifted to, actually this was our rectangle minus 1 by 2 to 1 by 2. Now it is shifted to the right side by 1 by 2, right? So it will be 0 to 1 by 2. Okay, sorry, 0 to 1, right? So this is valid there will be a value for this rectangle only from 0 to 1. So that is being multiplied with 2 cos 10 raised to 60. That is, it will be valid, it will be existing within this range only, 0 less than t less than 1. And now we will find out the energy. What is the formula for energy? Energy equal to integral minus infinity to infinity x of t the whole square dt, right? So that is equal to integral minus infinity to infinity, instead of x of t the whole square we are going to write 4 cos square 2 pi into 10 raised to 6t dt. So we will get, actually this is valid until from 0 to 1 only, right? 4 into cos square 2 pi 10 raised to 6t dt. We will calculate, instead of cos we will write 1 plus cos 2 theta divided by 2 cos 4 pi 10 raised to 6t divided by 2 into dt. From here we will get instead of cos it will be sine, right? Sine 10 raised to 4 pi into 10 raised to 6 t divided by 4 pi into 10 raised to 6, 0 to 1. This will be equal to 0 and the remaining will be 2. 2 joules is the energy of the signal x of t. Okay, so we got the answer 2 joule.